It is a unit of volume, so therefore we know my V for volume is given. As you recall, milliliters is not the correct unit though. You have to convert over to liters. The way I do so is I move my decimal over to the left 3 times. Move it over to the left 3 times. So 100 milliliters is actually 0.01, 0.1 liters. Move it over to the left, 0.1 liters. So that's given. Then it says it has a pressure of 688 millimeters of mercury. My P is also given. So my P and my V are given. Then it says it has a temperature of 565 degrees Celsius. Remember, Celsius is also not the correct unit. You want to make sure you convert that to Kelvin. So you're going to add 273 to that when we plug it in. Then it says how many grams of nitrogen are presented in this sample. Now you'll notice that grams is not technically a part of the formula. It's not P, it's not V, it's not N, it's not R, it's not T, but it is a component of one of them. It is a component of N. If you recall down here, you'll notice that N is grams over millimeters of mass. So this is actually a lengthier problem in the fact that you have to do one extra step at the end. So for number 16, we're actually solving for N because it has grams in it. It's the only one that has grams in it, so therefore you have to solve for N. So I've rearranged my formula, as you can see right here. PV over RT equals N. PV over RT equals N. I've written it out here with the units. So I need pressure, volume at the top, my R constant, and temperature at the bottom. So you'll notice, again, for millimeters of mercury, it's given right there. It's 688. So you go ahead and you plug that in, 688. That is millimeters of mercury. Then you got liters, which is your unit of volume. We've already converted it. It says 100 milliliters. You move it over to the left 3 times. So that actually gives you 0.1 liters if you've converted it to liters. Then at the bottom is your R constant. Remember I told you, you locate that at the bottom right of your formula sheet, bottom right. And you'll see there that for millimeters of mercury, you're actually going to use a different one than the one that you've used before. Remember you used 0.0821, which is for atmospheres. For milliliters of mercury, you'll actually notice that you are using 62.4. 62.4, you'll notice that at the bottom. I do want to make a note, as you can see right here, where it says torrs is equivalent to millimeters of mercury. So you'll notice here on your sheet, it doesn't have millimeters of mercury, it only has torrs 62.4. They're the same thing, so don't let that throw you off. Millimeters of mercury is the same thing as torrs. So you're going to use 62.4. 62.4 is your R constant. Remember to use the same exact units that are written on your piece of paper. So we got 62.4 millimeters of mercury is your R constant. So you got liters times millimeters of mercury over moles times Kelvin. That's given to you on this piece of paper once again. So that is your R constant. So you got PV, R, and then you're just missing T for temperature. It is given to you, number 16, but remember it was given to you in Celsius. You're going to have to add 273 to it. 273 in order to convert to Kelvin. So it gives it to us as 565, excuse me. If you add 273, that's going to give you 838. 838. All of these are given to you now. You're solving for number of moles, pressure, volume. You got your R constant and your temperature. We can, once again, cancel these units out if you want to make sure that you're doing this correct. Remember, millimeters of mercury, cancel each other out. You got liters down here, up here, excuse me, you got liters down here. Cancel each other out. You got kelvins right here, kelvins right here. All of them are canceled out except moles, which is what you're solving for. So you know you are doing this correct. You got moles right there equals N. All you have to do now, once again, is multiply across at the top, multiply across at the bottom. So we're going to multiply 688 by 0.1, 688 by 0.1, and that's going to give me 68.80. 68.80. And then you're going to multiply 62.4 by 838 at the bottom. 62.4 times 838 at the bottom, and that's going to give me 52,291. 52,291.20. 52,291.20. All you're going to do now is once again divide 68.80 at the top divided by your 52,291.20 at the bottom. It's going to give you a long decimal. Should be 0.001315. Yes. And then remember that that is your N. Now the final step that you're going to do is you're going to incorporate this formula. N equals grams over molar mass. Remember that you're not solving for N at the end. The problem says how many grams. So you've reached where you can calculate for N, but there's an extra step. You want to solve for grams for G, which is up here. Your N is given. So I've rewritten the formula over here. This is your N. Remember, I divided this by this and I put it here. This is N. Equals, grams is what I'm solving for, molar mass. You've already learned how to do your molar mass. That is your gas multiplied by how much of it you have. This time it says it's N2. N2. So if you look at your periodic table that I gave you with the average masses, you'll notice that the mass of nitrogen, which is N, is 14.01. 14.01. Since you have 2 atoms of the nitrogen gas, to incorporate into that molecule, you're going to multiply 14.01 times 2 because the gas is N2. If you're looking at problem number 16. So 14.01 times 2 is 28.02. So I put N2 down here so you know that that's what that is. So molar mass, bottom of the fraction line, N, grams. I'm solving for grams, remember? So here we have the formula. N equals mass over molar mass. You have 2 of the 3 in order to solve it. So the way you would do this is, since you are solving for grams and it's in a fraction form, just multiply across. So since you have nothing underneath, it's safe to say you can put a 1 under there. That's always something you can do in math. So 1 times grams is 1 gram, and then you're going to multiply these 2 in order to solve for gram. So once you multiply 0.001315, and then you're going to multiply it by 28.02, that's going to give me 0.0368. 0.0368. Our general rule of thumb is to have 2 decimal places after this, so you can technically make this 0.04 grams. That is my final answer, 0.04 grams. For number 16, that is how many grams of nitrogen you have in this problem. So as a recap, once again, your ideal gas law is PV equals nRT. PV equals nRT. Pressure, volume, number of moles are constant in temperature. This is number 16 in the problem. And you rearrange your formula in order to figure out for N, which is PV over RT. You plug that into your formula on that side. P is 688. My volume is 0.1. My R constant is 62.4. My T is for temperature. Remember, I've converted them. I moved the decimal 3 times to the left for my volume, and I added 273 for my temperature. I multiplied at the top, multiplied at the bottom. I got these 2. I divided this by this. I canceled out all of my units except for mole, which is N. I know I'm doing that correct. Once I got these 2, I put it right here into my next formula, which is number of moles is grams over molar mass. Multiply across. When I multiply these 2, I get that answer. Remember that I calculated my molar mass by taking N2, looking for it on my periodic table. You're going to find N is 14.01 times 2 because there's 2 of them. You're going to get that. Multiply across, your answer is 0.0368. You want to round it to 2 decimal places, it's 0.04 grams. Again, the tricky part about this is your R constant, know where to locate it, know which one to use, rearrange your formula correctly. Once you've done so, it's smooth after that.